Now we're getting very close to feed this information into the non-max suppression algorithm. But before we do that, we have this C variable here. So we know that X, which is right here as well, we know that the last index contained the value of the class, in our case, 2 in floating point. So if agnostic was true, then basically we would multiply 2 times 0, then that 0 wouldn't do anything. But given that we have false, we're going to multiply our value of 2 for the class times this variable here. And you might actually be thinking, why do we actually have to do this? And that is exactly what we're going to cover in this section. So the calculation of C is crucial for implementing batched non-max suppression that accounts for both class and spatial information. So let's break this down. We know that this is the value of the fifth index for each of these predictions. And when agnostic is set to false, as in our case, the classes of the bounding boxes are considered during the non-max suppression. So we're using the YOLOv5 pre-train model, which is looking for these 80 different classes. So how do we make sure that different classes do not overlap? Because we don't want to confuse the algorithm and suppress later in the non-max suppression step, suppress bounding boxes that overlap that are of different classes. So each box coordinates are offset by a large number, in our case, these 7,680, based on each class to separate boxes from different classes. So this ensures that boxes from different classes do not interfere with each other, and the ones with the same class will be close together in a space, while boxes from different classes are pushed far apart, preventing them from being suppressed altogether during the non-max suppression step. So in our case, our class index, 2, is multiplied by this value, and we obtain 15,360. And if we had other classes with high confidence, then the corresponding class would have been multiplied, and then the result would be very different, would be offset enough so that we would never confuse different classes during the non-max suppression step. So that is what this is doing. And in our case, this class offset, or C, is this value. We know that X are these values. So we know that our boxes are these indexes. So we're going to get these values, and then we're going to add this class offset to those, to each of these X and Y coordinates, X and Y and X and Y. And those values will be stored in boxes. And then the scores, well, the scores, that didn't change. The scores will be, in this case, these scores here, index 4. So we can run this unchanged. And then if we add this C, then we've offset it by 15,360. And well, the scores have not changed. And in this case, we're just going to feed it like this to the non-max suppression algorithm. So we can do the same steps here. And you can see that boxes is right here and scores right here. And we're also providing as an argument the IOU threshold of 0.45. So when we run this, you can see that I is basically tensor 0. But we're going to have to unpack this a little bit because there's a lot of information here that is very valuable. So the first thing is that the non-max suppression algorithm, we know that it takes these 3 arguments and then performs non-max suppression on the boxes according to the intersection over union. I know many of you already know the IOU, and then this algorithm iteratively removes lower scoring boxes which have an IOU greater than the threshold with another high scoring box. And the output will be a tensor with the indices of the elements that have been kept by the non-max suppression algorithm, sorted in decreasing order of scores. So we can run it here as well, and we're going to obtain 0 because, well, all of these predictions are for the car, and we're going to start with this one, the highest confidence. And we're going to compare to this one, the next one. And if we obtain an IOU that is greater than 0.45, then that one will be suppressed. And then we will check the next one, and then the next one, and then so forth. Given that they all overlap greatly, all of these ones are suppressed, and we obtain this one, which is in index 0.